Hi, my name is Jose Rodriguez. I am a Senior Partner Technical Specialist at IBM, and I'm going to give you a high-level overview of Spectrum Fusion. Now, Spectrum Fusion is a solution that will help your clients create and manage a containerized environment, specifically a Red Hat, OpenShift, and Kubernetes environment. Because of that, you're going to have the conversation about containerizations. Now, there's three different types of customers on the road to containerization. Very large enterprises more than likely are already in container environments. So the discussion about Spectrum Fusion may be a little bit easier with them. Now, medium to large companies, they may have started looking at containerization, maybe even started some pilot programs, or even moved things into production. And they've had some issues when they moved to production. So that might be the type of account that would be an immediate opportunity for Spectrum Fusion. Now, the SMB, you're going to have some accounts that are not considering containerizations, and you may have to. It'll be a longer cycle. You may want to have to become a trusted advisor to that company, so that when they're ready to go into containers, they know that you are available and may be able to help them. And one of the things you might want to talk to them about is why containerization. Well, with containerizations, applications and IT operations are much simpler because you're working with smaller units of workloads. The containers themselves are supposed to be very lightweight, so they quickly stop and start easily. They make them very portable. So from an application point of view, you can code it once and you can run it in almost any environment that's available. And for both applications and for IT, and I'll go into a little more detail, it'll make it more cost effective. Now, the medium to large may have already started a pilot, may even have moved things into production. And what are the issues that they've had when they moved them into production? And one of the things you might want to talk to them about, bring it up, is with a container environment, it's different. And you have to be able to ensure that you have high availability of an environment so that those containers are running, those workloads are running. There are different ways of protecting and securing the data. So bringing that into production can be a hindrance, right? You may have legacy storage. Container environments use storage a little bit different. So if you have legacy storage and you want to be able to use that, there are things that you have to do to be able to do that quickly. You've got to be able to meet the performance and scalability requirements. Scalability meaning how quick can I make my environment large enough to handle whatever requirement is there. And there's a skill gap. We don't have too many people that know and understand and can manage a containerized environment. So that makes it a hindrance to moving your pilot into production. All these things, what they do is the promise of containerization, the client may not be able to show its management all the promises of containerization because of project delays and cost overruns, because of application outages, not being able to secure the data, not be able to have it protected properly, which all reduces instead of increasing productivity. And if you set it up improperly, you can have an inefficient use of that infrastructure. Now, this slide I'm leaving here, but I don't want to talk about the disconnect between application owners and IT operations. Really what I want to show is the benefits to each of these areas of using a containerized environment. For applications, one of the very best benefits is portability. Being able to code that application without having to really have the consideration of what physical server it's running on, what OS it's running on, what peripherals I'm using, and be able to or be required to code to those specific environments. You can make your application very portable. You can break it up into lots of smaller little pieces so that you also are maintaining each little piece. When you want to add a feature or a function, you can easily do it by just adding those pieces that you need. If you need to create a fix for a bug that surfaced, you can work on only that particular container, that particular what they call microservice. And as a developer, you can be able to create that environment as a self-service, be able to pull down the pieces that you need from a central repository. Gives you the real flexibility of being able to create that application. And it gives you a consistent way of being able to create that application and those pieces no matter where they run. All of this, really what it helps is that the developer create its application very quickly. I'm not going to say minutes, but in hours, or be able to put out a fix rather than doing the whole application, just being able to do the piece of it. If you want to add a new function, being able to just add that function by adding a new container and a new way of calling that container from the rest of your application. Saves you in application development. From the operational point of view, what it does, it allows you to be flexible when it comes to capacity, but both in compute and storage. Get the capacity when needed, when required, and immediately from a different sources. Be able to provide that resiliency and that security to that environment very easily. And really what it does is allows a data center, an IT organization, to optimize its resources. So in other words, purchase really what's needed for most of your time. By being able to create instances of those containers in different areas, like let's say a public cloud, AWS, IBM's, or whoever else, you'd be able to, during spikes, be able to create those instances in those environments. And when the spikes are no longer required, be able to shrink it so you're no longer paying for that. So you're no longer paying on the on-premise side from infrastructure that you're not using. You're also able to not have to pay for public clouds by having that always readily available. And be able to, when those workloads are not required, be able to shrink them so you don't have to pay for that. So Fusion, what do we do? What is Fusion? It's really putting an Red Hat OpenShift Kubernetes environment along with Fusion, which provides the storage to it. Okay, now the container gives you application portability, but the data is also portable now. You've got security, resiliency, and backups, and we'll talk about that in a little detail. You can integrate with existing storage. So if you already have some block storage, or maybe even Spectrum Scale or Cause, we'll be able to use that as an instance. Everything is put together by IBM, enterprise level, and it's hardened. You can have file, block, and object type storage. And we also give you the capability to go out there to discover what type of storage you have, what kind of data you have, and be able to share it. In a picture, really what we have is up above, we have IBM Cloud Paks. That's one type of application that can use it. We've had all sorts of other types of applications that can use that environment that you can run. You've got Red Hat OpenShift Kubernetes to do the management, to create that containerized environment. And what Spectrum Fusion does is gets that container environment connected, integrated with storage and data services. Data services being the data protection, the creation of volumes of what they call persistent volumes, be able to provide the security for it, maybe even migrate data from one environment to another. And all of this can be run either on-prem or out in public clouds, or maybe your private cloud. How do we deploy Spectrum Fusion? Well, at the moment, there's two versions that you can go out there. We can have the appliance version, which is the HCI, the hyperconverged infrastructure. Basically, in a rack, what we've got the compute, we've got the storage, and we've got the network all built into it. So that all you have to do really is implement the actual applications. And then decide what type of storage you want to use and how do you want to, what data services you want to provide, what backup, recovery, maybe even what type of snapshotting you might want to do. Then we also have a software version of it, and the current release is for VMware. You can actually implement Spectrum Fusion along with the Red Hat OpenShift Kubernetes environment in a VMware environment. Okay. Roadmap, and very soon we're going to have the capability of running that Spectrum Fusion software on bare metal x86 servers. So that if you wanted to build your own HCI and you're on premise using the servers that you're used to, or maybe that you have special purchasing power for, we'll be able to do that. You can also then run it on Microsoft Azure, Google Clouds, AWS, and IBM Clouds, giving you that capability of expanding your workloads into those public cloud environments if you need it. I'm going to talk about the three main components or benefits of Spectrum Fusion when you use that environment. If you want to back up your application, or if you want to do some migration of it, you can use a component of Spectrum Fusion. It really is part of a Spectrum Protect Plus environment. You can back up your data into S3 buckets. Either IBM Cloud Object Storage, whether you have it running on-prem or whether you've got the service out of the IBM Cloud, or into Microsoft Azure S3, or other public clouds that use S3 protocols for their data. Okay. Then you can use that data to restore to any point in time in multiple places. You can create policies so the backups are done automatically for you. And those backups, you can either have application or crash consistent, depending on what application it is. And you'll be able to restore that data to different Spectrum Fusion instances. So in other words, you're migrating the application from, let's say, your on-prem to AWS, or from AWS to IBM Cloud, because now you're going to drop your AWS subscription. Another great benefit is that you can have the data in one central repository, and multiple Spectrum Fusions can actually get to that data, manipulate that data. And it can be Spectrum Scale, it can be a NAS filer, or even an S3 bucket, as we mentioned before. You can use that as your central repository. Now, if you have multiple Spectrum Fusions running and you want better performance because you don't want, let's say, the Spectrum Fusion that's running in AWS to have to traverse all its way down to your central Spectrum Scale, you can actually have caches. You can have copies of the data that you need at those local Spectrum Fusions so that they get Spectrum local performance requirements are met. But yet you still have a centralized repository that has maybe your data or place of central place where you have all your data held. You can have the data, that cache, be prefetched and ready in the mornings if you want, or you can have it set up so that immediately when some updates are made, they are also made to your central repository. Okay. A third benefit is by using Spectrum Fusion to manage your data, you can have synchronous replication between multiple instances of Spectrum Fusion, so that your RPO is 0, or because whenever a write isn't done into, let's say, zone 1, that write is also done to zone 2. So that if zone 1 goes away, you can immediately start running off of zone 2. Now, to be able to do that, you've got to have metro area. The two instances have to be close enough so that the latency isn't too great. Now, if you want geographical dispersed replication, so that the zones are not so close to each other, so that if one event doesn't break down both zones, you can have asynchronous replication. What that does is it gives you the capability of being able to recover in case of a large event, and you've got the replication further away. But there's going to be a little more latency, so the RPO may be near zero, but it won't be zero. Okay. So that gives you a brief high-level overview of spectrum fusion. Here's some more links on getting more information about spectrum fusion, also about Red Hat OpenShift, and about IBM Clouds, because they really are, the spectrum fusion is really built to be able to handle those workloads very quickly. If you need any additional information, if you want more detailed information about spectrum fusion, if you want a deeper dive presentation, get in touch with any one of these three Ingram Micro contacts, and they can set up something for you. With that, I want to say thank you, and I also want to remind you that this is only one of a series of enablements, recordings that are out there in the Ingram Micro YouTube channel. Again, I want to thank you.